Welcome to an insightful hour with Spyrosoft's podcast series Make It Easy, where we free dive into the world of technology in the automotive industry. I'm your host, Catalin Vochita, and today we have an exciting episode lined up for you all. Joining me is our local specialist on Adaptive AUTOSAR from Spyrosoft Romania, Ioan Harangus. I know your colleague called you Titi in the office, is that right? Maybe we can do the same for today's session?
Hello, Catalin. Yes, you can call me Titi.
Nice. Then we are off to a good start, I can say. Already agreeing on things. That's nice. Titi, is this your first podcast? Maybe can you tell us how do you feel today surrounded by those lights, cameras, mics, and so on?
Well, yes, this is my first podcast, but I was used to make public speaking during my trainings performed in the previous company. Also, I was performed in my first webinar some time ago, some 1 month ago, and I was speaking to in front of cameras with a lot of microphones, and yes.
That sounds great. If you have experience with talking to the crowds, honestly, it means that will be a simple walk in the park for you today. Maybe can you tell me a little bit more about yourself? For example, when did you start your journey in tech industry, or when did you choose AUTOSAR? Something like that. When you changed from AUTOSAR to classic AUTOSAR to adaptive AUTOSAR, if this is the case, or just go directly to the AUTOSAR adaptive.
Well, my tech journey was started some maybe 32 years ago when I was graduated in automation, and I was hired in Institute of Research in Automation, and where I completed my project for the diploma for my studies. And then for 1 year I was increasing a lot in my tech knowledges in this institute. A lot of software improvements I was learning during this great experience in this institute. Then 1 year later, I was hired by a telecom company, where I was working for at least 25 years.
Nice.
Yeah, and then there I was dealing with a lot of activities like tester, software engineer, integration engineer, also software developer, and dealing with a lot of projects, starting from maybe digital switching, central, and then coming to the mobile, telephony, and then starting from 2018, I was started to work in automotive domain. I was hired by software automotive company, and I was started directly in Adaptive AUTOSAR, from starting this project in Adaptive AUTOSAR platform provider. And then, of course, I was started to work directly in Adaptive AUTOSAR. Why? Because I was quite experienced in Linux and sometimes in C++ programming language, which is the two main characteristics of Adaptive AUTOSAR.
Then Titi, based on your experience, because it's a great experience, can you maybe tell us why do you need Adaptive AUTOSAR?
Well, let's see what is AUTOSAR. AUTOSAR, it is normally a software platform which is needed which is built in layers, and which is needed to separate the hardware from the software, to adapt the applications in order to make a standardization of these applications, software applications, and to could easily install these applications no matter the hardware. So AUTOSAR was founded by a consortium of OEMs and tier 1 suppliers in automotive industry, like for example BMW, Daimler, Bosch, and so on. And this AUTOSAR consortium created the specifications for this platform, and later on there were several providers of this platform, and is built on layers, and it was intended to be used for normal features to control basic features for a normal car. For example, a diesel engine to control the braking, to control also the consumption of engine and so on. And later on, during the years, the electromobility appears. Also, ADAS, advanced driver ADAS system, and then autonomous driving, which is the normal driving for adaptive AUTOSAR. Why? Because for doing this autonomous driving, we need to process a large amount of data. For example, to recognize the obstacles, to make also autonomous driving, to recognize the traffic lights, the traffic lanes, and also the obstacles. You need to process a lot of information coming from sensors, or smart sensors like LiDAR, radar, or cameras. And this fantastic bunch of data needs to be processed by complex algorithms, for example, and these learning algorithms need to be processed in high performance controllers, computers. In these high performance computers, we need to install several virtual machines. In some virtual machines, we need to install either classic AUTOSAR systems, platforms, using, for example, OSEC operating system. In other virtual machines, we need maybe to install adaptive AUTOSAR systems, platforms, together with POSIX-like operating system. And so, above all, we will install, for example, adaptive applications, which are running in these virtual machines, providing some features to this car. And of course, we need also to think about to change the architecture of the car, the software architecture, but also the hardware architecture.
But Titi, please tell me, let's say it's for my curiosity, does that mean that adaptive AUTOSAR came together with an autonomous driving system?
Well, let's clarify the things. Adaptive AUTOSAR will not replace classic AUTOSAR, firstly. So adaptive AUTOSAR will enhance the features for the car. It will be used in parallel with classic AUTOSAR, because classic AUTOSAR provides normal features for the car, but adaptive AUTOSAR will provide enhanced features for the car of tomorrow. For example, there are three main features which are using adaptive AUTOSAR. There are, for example, update over the air. You know, in the past, we had fixed telephony. Yeah? Now we almost use no more this fixed telephony. We pass to the digital telephony, mobile telephony. It is the same evolution now for the automotive industry to go from classic AUTOSAR to adaptive AUTOSAR, from software which is not updated for the life of the machine to software which will update very frequently with new software versions, with new software applications, with new maybe operating system versions. Even hypervisor could be updated. This is the first feature. The second feature, it is the electromobility, where we'll have electric cars will be charged with energy using smart charging stations. we need to measure the quantity of energy transferred from these smart charging stations. Even wireless charging could be possible. Yeah.
Okay.
And the third feature is, for example, autonomous driving. Yeah.
You already give us some examples of the applications, let's say, developed using Adaptive AUTOSAR, right? This is kind of application where it is used Adaptive AUTOSAR. But maybe just for, let's say, our audience, because I'm pretty sure that they are eager to dive deeper into the technical aspects, could you tell us about the unique features that set Adaptive AUTOSAR apart and how it impacts the industry's development?
Well, like I said before, for example, before when, let's make an analogy with telecom industry. There was a revolution in telecom industry in the beginning of 2000 years to what 2000. For example, in the first part of the mobile telephony, we use only the mobile phone only for dialing and for SMS messaging. Then later on, smartphones appeared, okay? And these smartphones make a revolution in using these mobile phones. Yeah? In order to, for example, to increase the data exchange, to use the application on the mobile phones, so like a mini laptop or a mini PC. The same is happening now for the cars. The car is maybe electromechanical system which allow us to go here from here to there, okay? But we need to make things differently. I mean, to go to software-defined vehicle, I mean, for example, to have a car which we can increase the normal feature installed in this car using the software. To, for example, to add more functionality to the car only using the software updates like we use for the smartphones. Yeah? From distance, for example, you have a problem in the car, you can, for example, diagnose this problem or the issue remotely and maybe even repair the car remotely by restarting some processes, restarting maybe a system or a virtual machine or a ECU. This could be happening in the near future. Also, we could, for example, manage a fleet of cars remotely using cloud technology to install these kind of systems remotely and to see where each car of the fleet is going and coming and so on. And also we could think of tomorrow to use the cloud technology in order, for example, for the platform providers to use continuous integration, continuous delivery, using the cloud technology where we have large computers where you could launch nightly a bunch of tests to increase the performance of our software. Also, the cloud technology could be used, for example, to process a large amount of data and to communicate them to the cars, to vehicles, could be maybe small cars, passenger cars, buses, trucks, and so on.
But Titi, if I understood correctly, let's say this technology, Adaptive AUTOSAR, is more suitable for those high computer power, right? Or this kind of technology, it's very easy to use also for small ECUs, like we have, for example, the actual architecture in the car. We have a lot of small ECUs, right? And for me, at the beginning, let's say it looks like this technology is more suitable to those big ECUs, high computer power, cold, and so on. Is this the case, or even we can use, let's say, Adaptive AUTOSAR on some small ECUs and that's it?
Well, not quite. The problem is the architecture. The present architecture means that we have maybe 100 or 200 of ECUs installed in all the car. Also a lot of cables with different protocols, communication protocols used like CAN, LIN or MOST or yeah. And this is very not very efficient using of the communication because we have a lot of cables, a lot of wires. The communication is not very fast and a lot of data could be exchanged using these protocols and using these wires and cables. So we need to rethink the architecture of the hardware architecture and software architecture in the car, going towards central architecture, zonal architecture. For example, we have a high performance computer. We will install inside this computer several virtual machines, and those ECUs will run inside some virtual machines which will be installed and configured in this high performance computer and communicating using, for classic AUTOSAR, we can use CAN, LIN, and MOST. And for adaptive AUTOSAR, we can use some IP and automotive Ethernet to perform the transfer of great amounts of data. Also, we can use wireless communication using some applications, for example, UCM master in order to make the software update over the air, or even by cable into some repairing facilities.
But maybe can you tell us a little bit more about some IP? It's a standard, a protocol, what it is?
Some IP, it is a protocol which came to be used in automotive industry, which is based on service-based communication. It is a fundamental protocol used for service-oriented architecture. I mean, for example, you have two applications who needs to dial or to communicate to each other. So there is a provider and a requester of some data or some information, or maybe some other bunch of information. Could be files, could be parameters.
Okay.
Yeah. So between the two applications, we have a communication layer, a communication cluster in each platform, because our applications could lie in different virtual machines or could be installed in the same virtual machine. Some IP is used to communicate to different virtual machines, to two applications which are lying in two different virtual machines. And this communication cluster, which is a service registry, the service provider provides the information to the service registry, to the COM cluster, into our adaptive platform. And the service requester, so the client, will try to find this service information into the service registry. And as soon as it is found, the communication is taking place. And like that, the applications providers could only deal with applications needs and features, not dealing with the details, the parameters concerning the communication. This is the problem of the communication cluster. But the problem is that this some IP implementation and configuration takes a lot of effort in order to be implemented. But the problem which will be solved later on, then it will be dealing very fast the communication and using, for example, IPC communication. And IPC communication, in order to transfer a large bunch of data, you could use, for example, shared memory.
But Titi, looks like, let's say, the adaptive AUTOSAR is the future, right? Maybe let's do a short creative exercise. Let's suppose that currently I'm working with classic AUTOSAR, maybe.
Yeah.
I'm a good one, let's say, medium. And I'm looking for a new challenge. I would like to continue my career working with this kind of technology, with to switch from classic AUTOSAR to adaptive AUTOSAR. What's your opinion? Give us some advices. Tell us what I need to improve on myself to be able to change to adaptive AUTOSAR.
Well, it is a good question, and I think it is a question which I could answer. Firstly, we need to go to see what are the main characteristics of adaptive AUTOSAR. For example, in order to deal with adaptive AUTOSAR, you need, for example, basic knowledges on Linux operating system or POSIX-like operating system. It depends now. If you go as an integrator or a tester, you need maybe more Linux knowledges in order to adapt, to configure all the kind of stuff in order to, for example, to configure the applications to be installed and tested. Also, as a tester and integrator, you need maybe a shell scripting language knowledge, or maybe a Python learning programming language in order to make some automatic test scenarios. But as a software developer, you need to improve on C++ programming language. I mean C++ 11 or 14, because we need to use the latest features of this powerful language. And why C++? Because normally in Adaptive AUTOSAR we deal with complex algorithms and using a large amount of information, using, for example, learning technology, machine learning technology, where there are complex algorithms to be running and to be used. Also for adaptive applications, we use C++ programming language, and there are sometimes complex applications to be created. So you need C++ programming language to, for example, to go from C language to C++, to object-oriented programming, and also maybe to be flexible, and in the last phase maybe to go to the standard and take all the APIs to be used in these adaptive applications. There are very fixed specifications in order to, for example, signature of these APIs are specified in the standard, but if you know C++ programming language, it is not very difficult to use them.
Okay, then as a conclusion, looks like, okay, if I want to, let's say, continue my career and develop some applications in Adaptive AUTOSAR, I need to upskill into C++, if I remember correctly. And also, if I want to, let's say, go a little bit deeper, I need to go and check the protocol and the standards used in Adaptive AUTOSAR, right?
Yeah.
Good. And maybe can we have a comparison between classic and adaptive? You started a little bit, let's say, the application layer, we can say, okay, on one hand we have C, embedded C, in the other hand on adaptive we have C++. Can we have a comparison between those two technologies?
I already mentioned C++ and Linux, which are the main characteristic of Adaptive AUTOSAR compared to classic, where it is an OSEC operating system used, and C programming language. There is, for example, a strict memory space to be used in classic AUTOSAR as comparing to Adaptive AUTOSAR, where each process and application is running in its memory space. For example, a container, application container. Also, another difference is that we use service-based communication in Adaptive AUTOSAR compared to classic one, where you use signal-based communication. Of course, there is a possibility to communicate from classic to adaptive, but you need a gateway between signal-based communication and service-based communication to adapt this kind of protocol to communicate to some IP. Also, there is, for example, automotive Ethernet is used in Adaptive AUTOSAR. In the other part, we use the CAN, MOST, and LIN protocols.
You mentioned about service-oriented architecture. Maybe can you tell us more about the main roles of service-oriented architecture, something like that?
As mentioned before, there are three actors there. There is the service provider, an application which provides some information in order to be used by other applications. There is some consumers of this information, service requester or the client. And the third role is played by the communication layer, which is a service registry or a broker of this information. So the service provider provides this information to the service registry, to the COM layer, and then to the COM cluster, and then the service requester try to find this information to the service registry, to the communication cluster. When it finds it, the communication is started to be taking place. If not, there are some errors and the communication is not taking place if it is this information is not found into the service registry. Yeah.
Nice, really nice. I really enjoy the conversation. Now, Titi, let's go a little bit deeper, I would say, and we will have a look from macro perspective. I'm interested into this technology and how this technology is evolving in Romania, especially, let's say, in Romania, how this feels to you.
Well, if you go and search in the normal social media, you can see that there are a huge amount of requests for the classic AUTOSAR, because there are a lot of components, software components and applications to be created for different OEMs, for different tier 1 suppliers. But I think more and more adaptive AUTOSAR is requested, starting from since several years. And it will increase this request sharply in the coming years. Why? Because it will start to be used a lot more intense, the electromobility, the electric cars. Starting from 2035, the main part of the fleet will be electrical. Also, update over the air feature will be very intense used and installed in these electric cars. And of course, autonomous driving, which is a huge breaking technology evolution, because this is quite a revolution in automotive industry, because it means that we will decrease a lot the number of accidents, and the safety will increase sharply. And like that, we need a lot of developers and designers to create these adaptive applications, to create these adaptive platforms and to increase their functionality. Now, as far as I know, they work for the safety. For this adaptive AUTOSAR platform, we need to increase the safety of our Linux operating system to ACLB. Yeah. I think it is the by default request for this adaptive operating system. When we talk about automotive operating system, we not talk not only about Linux or Android or QNX, a POSIX-like operating system. We talk about the middleware, I mean the adaptive AUTOSAR platform, but also we talk about hypervisor, which is a management cluster which deals with and handles, manages the running in parallel of several operating systems installed in different virtual machines in the same high-performance computer.
Looks nice. Maybe let's go a little bit deep. Can I ask you about Spyrosoft, how it looks in Spyrosoft, this trend, or what's your opinion about that?
In the present day, for Spyrosoft, there is it starts to increase the needs to go to adaptive AUTOSAR. The main part of our colleagues works for classic AUTOSAR, but the adaptive AUTOSAR is increasing for several months. For example, I work for a project directly for OEM, We only are maybe a few colleagues, but we start to increase the number of colleagues. We work for this OEM, important OEM, and it will come interesting to go further. For example, we have now some design activities, but I think and I hope that in the future we will try to take some maybe testing and integration activities for this OEM. And it is very interesting because we are a small company and we go directly for OEM, working for OEM. I think it is a very good start and it is a very good experience, and I think we are very well appreciated by these OEM, so car manufacturers.
I think we are the smallest tier 1, right? Declared in the last period. I saw something on the internet, it was published, looks like. Okay, and maybe a curiosity also from my side. I know that you worked before for a company where you worked on the development of the AUTOSAR adaptive platform. Now, in Spyrosoft, are you using the know-how that you increased before in the previous company? Are you doing the same thing? You have the chance to do something else more, maybe?
Well, interesting. I was changing the company because I needed to go and perform different activities to increase my competencies and knowledges. So not quite the same activities I perform now for Spyrosoft. For example, I go to debug some issues in unit tests, but before I was in an integration team and lead integration team, and also performing some deliveries of our platform to different clients, customers, using database where I was stored these adaptive platform versions, and also dealing with as a release manager with approving these deliveries, and also making some automatic tests using Python language, platform for tests using Python language, but also restructuring these automatic test scenarios and adapting to object-oriented technology. Yeah. Now I think and I hope that we will deal also with Adaptive AUTOSAR standard, because as performing this unit test, it means that I go mainly to use the C++ programming language instead of having the big picture of Adaptive AUTOSAR system as an integrator or using these adaptive applications. I not have now contact with the adaptive applications created by our colleagues from this OEM, mainly because we only test some small methods or functions or objects in order to increase the quality of the code.
But it is interesting because it looks like before you let's say develop the platform, now you have the chance to use it somehow.
Yes, of course. Well, when I was in this platform provider company, I was performing integration activities, but during these integration activities, in order to test the platform, we use some adaptive applications. So sometimes I corrected some issues on these applications. So I dealt with some corrections on using this C++ programming languages, and also installed and configured these adaptive applications. But now I'm doing less with these configurations activities, and I hope that in the coming months maybe we could start to use my knowledge, integration knowledge and testing knowledge for these new project activities. I hope that in the coming days we will try to gain more activities performed for this OEM. But for the moment, it is only this kind of activity I perform. Also, I perform these webinar activities. I also use my knowledge during my learning and teaching activities in order to perform these webinar activities, some maybe 1 month ago.
Nice, really nice. And maybe Titi, can we go a little bit from the structure of the company perspective? We know that, let's say, Spyrosoft is a service company, right?
Yeah.
And from the perspective of service company, how do you feel about this fast-moving environment? Because, you know, it's a more dynamic environment in a service company than in a product company. How it is for you?
Well, it is a big shift for my activities. Because why? Because in the past 32 years at least, I was working for a product company. Like for example, in telecom company, I was developing, for example, mobile systems or digital switch systems, and increasing, adding some new features and new activities, new product. But also working for the Adaptive AUTOSAR platform in this platform provider company. Also, I work, for example, to build this platform, to test this platform, to configure this platform, and then to add features. But in a service company, for example, you could switch for using this platform to add applications to this platform, to test them, and then to deliver them to the customer. It is a kind of new activity for me, like in tennis, for example. Yeah, a provider, like when you serve, yeah, you provide something to the other player. Now I am a receiver because I receive these functionalities from this platform company provider, and using these services in order to build our applications requested by our OEMs. Also, we could think like, for example, for smartphones. Before we have only the mobile phones. Now we have smartphones. I think now we have cars, normal cars, diesel engine cars.
Maybe just to interrupt you a little bit using this example because it's a really good example. Can we look into the perspective a little bit and maybe from your opinion, where do you think Adaptive AUTOSAR will go to from here on?
Well, the Adaptive AUTOSAR standard drive us to the revolution of automotive industry. Why? Like in the telecom industry, we go from normal mobile phone to smartphones. I think now we go from normal cars to smart cars. Smart cars, sometimes named as software-defined vehicles. What is this software-defined vehicles term used for? Well, it describes a normal car, electric car mainly, which is very frequently updated with new software versions, updates for applications, for our platforms, for even operating system. Yeah. Also, we need to think about using the cloud technology. Why? Because software-defined vehicles will communicate to software cloud servers, but also to other cars. Why? In order to perform autonomous driving, we need to communicate to other cars, to other systems. Also, to manage the fleet cars, we need to communicate to a server which manages this fleet of cars, which is lying maybe in a public or a private cloud server. Also, we need to think about using this Adaptive AUTOSAR in order to provide information to other systems, like, for example, using Netflix, Spotify, but we need to adapt this usage of this social media with the restrictions of legal restrictions in order to drive a car. Well, using this in social media when the car is not running. Yeah.
Good. Titi, I can say that time flies when you are exploring exciting tech, exclusively together with you. Before we conclude, Titi, could you share, let's say, your vibe at Spyrosoft, how it feels regarding how the people development, transparency maybe contribute to the company's growth and innovation?
Starting my activities here in Spyrosoft was I was very warm welcomed by my colleagues, even if my colleagues were not very old in this in this company, because our company is 1 year old here in Romania. I was very warm welcomed. Also, I was excited to work in a new company. Also starting to work in a new technology as Adaptive AUTOSAR, the new projects. Also, I collaborated very well with my colleagues from OEM, also my colleagues from Poland or from Croatia, from other countries. There is a very well a collaboration with our Romanian colleagues, and I try to help them with my great experience in many domains. Like, for example, I try to help my colleagues from quality in order to, for example, to provide them some information about open source software. Also preparing my webinar in order to spread my information on Adaptive AUTOSAR to my colleagues, which mainly deals with classic AUTOSAR. And now I hope we will take more colleagues in this wonderful technology. Yeah.
Super. Titi, I would like to say thank you for all the info shared with us today, and maybe see you next time.
Okay, see you to our next episode, and thanks a lot for your attention. Thanks, Catalin, and see you. Bye.
Bye.